So today we're going to talk about the trapezoidal rule, which is going to be another way to find area between a curve and the x-axis. And we're going to use trapezoids instead of rectangles. But everything pretty much is the same thing. It's just going to be a trapezoid, okay? And what is a trapezoid? Well, trapezoid has two parallel or a pair of parallel sides. So that would be these two right here, all right? And then our height. And the height of any trapezoid is always perpendicular to the bases. So what's going to wind up happening is this h is our delta x. And so in this case right here, this h is delta x. And so these are going to be function values, but we need the left side and the right side of each trapezoid in order to find the area of this trapezoid. So this b sub 1 is going to be f of x sub 1. And this is going to be another function value, f of x sub 2. So this b sub 1 right here, we could replace with f of x sub 1 plus, and this b sub 2 would be f of x sub 2. And it's just the two sides, but those are going to wind up being function values. All right, so let's do our first problem. So we're going to use 4 equal intervals. We're going to estimate the area under the curve for f of x is equal to negative x squared plus 16 for 0 less than or equal to x less than or equal to 4. So we're going to do this between 0 and 4. And here you can actually see one of the trapezoids right here. And then here's a second one, and here's a third one, and here's the fourth one, okay? So the very first thing is we got to figure out, okay, what's our delta x? Well, we're going to start this at 0 and we're going to end it at 4. So the way we calculate our delta x, which is going to be the height of each of these trapezoids, is going to be 4 minus 0, same way we've been doing it. So 4 minus 0 divided by however many we want. In this case, we want 4 equal intervals. So that'd be 4 over 4, which is 1. So each of these, and we could read it off the graph too. Okay, each of these, our delta x would be 1. All right. So if we want to estimate the integral from 0 to 4 of our function f of x dx, we can estimate that by using a trapezoid. And the area of a trapezoid, I should have said it earlier, but I didn't. Okay, the area is 1/2 the height times the sum of the bases. Again, these are going to be function values, and this is going to be my delta x. All right. So back to this, we're going to have 1/2 times our height of this first trapezoid. So that'd be 1 times, and the left side of this trapezoid is going to be f of 0, and the right side is going to be f of 1. So this would be f of 0 plus f of 1. Okay, that's our first trapezoid. Now we have to add our second trapezoid. So 1/2 times 1 again, because this second trapezoid, its height is 1, its delta x is 1, times, and this is going to be f of 1 plus f of 2. And then I'm running out of room, so I'm going to wrap back around, and I'm going to add 1/2 times 1. And now I'm working on this third trapezoid. And so that would be f of 2 plus f of 3. Plus, in our last trapezoid, 1/2 times 1, because that's 1, and then f of, and this would be f of 3 plus f of 4. Okay, so cleaning this up a little bit, we would have 1/2 times 1 times, and f of 0, if I put 0 into the function, I'm going to get 16 out. If I put 1 in, that'd be negative 1 squared, so that's going to be plus 15. So 16 plus 15. And then plus, and then 1/2 times 1 times, and then f of 3. Well, 3 squared is 9, so this would be negative 9 plus 16. You know what? I'm sorry. I'm right here. F of 1, putting 1 in would be 15. And then f of 2. I said the wrong thing. I actually was going off this one, and I should have been going off this one, okay? So f of 2, so I need to put 2 in here. So that 2 squared would be 4. So negative 4 plus 16 would be 12. So this would be 15 plus 12. And then plus and then 1/2 times 1 times, and now we're f of 2. So f of 2 would be 2 squared would be 4, negative 4 plus 16, 12, and then plus, and then f of 3. 3 squared is 9, so this would be negative 9 plus 16, which would be 7. And then the last one would be 1/2 times 1 times, and then f of 3, 3 squared again is 9, so that'd be 7 plus, and then f of 4, 4 squared is 16, so negative 16 plus 16 would be 0. So this would be plus 0. And actually, this last little piece isn't even a trapezoid, it's actually a triangle. But you could actually use, a triangle is just a trapezoid where one of the bases has become 0, okay? All right, so cleaning this up again, all right, this would be 1/2 times, and this would be 31, so that'd be 31 halves plus, and this right here would be 27, so 27 halves. And this would be 19 halves. And this would be 7 halves, so plus 7 halves. And that gives you, if you add these up, it's going to give you 84 halves. And 84 halves, an estimate for this integral would be 42. So that's how you do it. Okay, so you have to be able to do a left rectangular approximation method, a right rectangular approximation method, a midpoint approximation method, and then this one with trapezoids. Okay, so there's 4 ways to get the area between. Well, there's more than 4. These are just 4 that I expect you to know. Okay, is the left one, the right one, the midpoint, and then this trapezoid one. Okay, all right, let's do another problem. In the last problem, all my delta x's or my trapezoid heights were all the same length. In this case, we want to estimate the integral from 1 to 20 of f of x dx using 4 unequal partitions. Okay, so that's going to be a key word, 4 unequal. So they're not going to all be the same length. So basically our delta x in the first one, and we want to go all the way from 1 to 20. So our first one, this is going to be our first delta x, or our h1, our first height, and it's going to be 2. All right. And then from 3 to 4, that's going to be my second height, but that's a difference of 4. And then from 7 to 12, that's a difference. That's going to be my third height of my trapezoid. And so that's a difference of 5. And see, they're not always the same, right? And then from 12 to 20, that's going to be my last height of my trapezoid. This is going to be the left side base. This is going to be the right side base. Okay. So if we want to do this, we're going to integrate from 1 to 20 f of x dx. That can be estimated, all right, with 1/2 times. And so from 1 to 3, that'd be 2. And then times, and then we're going to have to add. These are my 2 base heights, right? 4 and 8. So 4 plus 8. And then plus 1/2 times, and then the next one is going to go from 3 to 7, so that's a height of 4, and then times, and this one would be, the left side would be 8 and the right side would be 15, so 8 plus 15. These are the 2 side lengths that are parallel to each other, and then plus 1/2 times, and the third one goes from 7 to 12, so that's going to be 5 times, and it's going to be 15 plus 7. That's the sum of the bases. I'm trying to say it different ways, so if you don't understand it one way I'm saying it, you'll understand it a different way. And then we went from 12 to 20, so that's 8. And the sum of these 2 bases would be 7 plus 9. Okay, so half of 2 would be 1 times, and this would be 12, plus, and half of 4 would be 2, times, and then 8 plus 15 would be 23. And then plus half of 5. Actually, you know, if it's hard to, maybe this will come out to be an even number and we'll be able to have that. So what is 15 plus 7? And that'd be 22, right? So half of 22 is 11. So you could write this as 5 times 11, because I took half of this because that one was even. Then this one, half of 8 is going to be easy to do. So half of 8 is 4, and then I'll put that in parentheses, and then 7 plus 9, that'd be 16. So for this one, you could either take half of 8 or half of this sum, okay? And either way it works. Just don't take half of both, all right? That'd be the wrong answer, all right? So then here we get 1 times 12, that'd be 12, plus this is 46, plus 55, and then plus, and 16 times 4 is 64. And then if we add those together, this integral could be estimated with a value of 177. All right. So pay attention, okay? When we say unequal, that means the delta x's, okay? In this case, the heights of the trapezoids are going to be different lengths, and they can be, okay? They can be. They don't always have to be equal lengths. A lot of times they are, but they don't have to be, okay? So these two right here are exaggerating something to really show what happens, okay? If we're using trapezoids and the function we're integrating is concave down, like this one is, okay? If that would mean f double prime is less than 0, right? That would mean it's concave down. If you know the second derivative is always going to be negative and you're using a trapezoid, then this is going to have to be an underestimate, because look at all this gap in here, right? We're not picking up this. Even if we squeeze these two sides together and make this a skinnier trapezoid, it's still not gonna, it's gonna have this gap in between the trapezoid and the curve. So we should realize that, okay, if it's concave down, then the estimate that we get from this would be an underestimate. Because we'd be missing this little white part up here, okay? And if we're concave up, that would mean f double prime is greater than 0. Then that would mean we're concave up. Okay, and if we're concave up, then we have more area, right? We'd only want this area right in here underneath the curve, right? But we have this extra area. So if we have concave up, when we go to do our estimate, it's going to be an overestimate. So this is just an easy way to show you why one's an underestimate and one's going to be an overestimate. Okay. So how do they tell you? How do they tell you if it's concave up or concave down? Then they're going to tell you something like the second derivative is always negative, or the second derivative is always positive, and then you're going to be able to state whether it's an underestimate or overestimate based on the concavity of it. They would never give you one that changes concavity, you know, because then you wouldn't be able to determine whether it's an underestimate or an overestimate. Okay, they wouldn't even ask that question. Okay, if it was changing concavity. So this next problem is a problem from an old AP exam. It's one from when I first started teaching AP calculus close to 15 years ago, okay? Long time ago, all right? So here we go. We're given a table of values. We're given the number of people here. L of T is the number of people. And so concert tickets went on sale at noon, T equals 0, and were sold out within 9 hours. The number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable function L for 0 less than or equal to t less than or equal to 9. Values of L of t at various times t are shown in the table, okay? So this is the number of people in line, okay? So yeah, if they sold out 9 hours, right, there's not gonna be anybody in line because they sold out, right? At 8 hours, so that'd be 8 p.m. because noon is t equals 0. So this is noon, right? There's 120 people standing in line. At 1 p.m., there's 156. At 3 p.m., there's 176. So these are just snippets in time, right? We're telling you how many people are in line at that particular time, all right? So use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30, which is t is equal to 5.5. Show the computations that lead to your answer. Indicate units of measure. All right. So this is a traditional problem on the AP exam, okay? Pay attention to this because they're asking you to estimate the rate at this time. That's a derivative. So really what they're asking you to estimate here when they say the rate, right? Estimate the rate. They're asking you to estimate L prime of 5.5. Well, we don't have 5.5. The closest we have is 4 and 7. So we can use these, and we can use a slope between these 2 points to estimate this rate. Okay, so this is approximately, okay, we can do L of 7, and this is just slope of a line, minus L of 4 over 7 minus 4. Okay, so what is L of 7? L of 7 is 150 minus L of 4, which is 126, over 7 minus 4, or you could write 3. So 150 minus 126, that would be 34. 24 rather, 24, not 34, 24 divided by 3, which is 8. Now, what are the units? Well, the L units are people, and these are time units, so that was in hours. So this is people per hour. Okay, and it's as easy as that. I mean, a lot of AP exam questions are very simple, straightforward like this. You just have to understand like what they're asking, okay? All right, not hard computation, okay? It's just you have to understand what do they mean by estimate the rate at which the number of people waiting in line was changing, okay? And that's a moment in time, so you should be thinking, oh, that's a derivative, okay? All right, let's use this next one, okay? So this next one is we want to use a trapezoid sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours that the tickets were on sale. Okay, so we want to find the average number. That's the average of L of t, right? From 0 to 4, because that would be the first 4 hours, okay? So that means we have to do 1 over 4 minus 0, the integral from 0 to 4. Because remember, if we go 1 over b minus a, the integral from a to b of the function, that's going to give us the average value of the function. And that's actually what they're asking you to do here, okay? So this would be L of t dt. And so that would be 1/4 times the integral from 0 to 4 L of t dt. Okay, so we can get this estimate by taking 1/4, and we're going to use trapezoids, okay? So this is going to be, and I'm using a bracket here because I need to multiply this integral by 1/4. So it's going to be 1/2 times, and if we go from 0 to 1, this is my first height, right? This is my delta x. It's going to be 1 times 120 plus 156. That's my first one, right? And we want to do this with 3. So plus 1/2. And now we're going to go from 1 to 3. That's a difference of 2. So 1/2 times 2 times 156 plus 176. Plus 1/2. And then we're going to go from 3 to 4. And that's where we're going to end it. Well, that would make my height of my trapezoid, okay, which is really my delta x, 1 times, and it's going to be 176 plus 126. Okay, so this is 1/4 times, and this would be 1/2 times, and if we add these, that'd be 276 plus, this would be 1 times, and 156 plus 176 would be 332 plus 1/2, and 176 plus 126 would be 302. Keeping that 1/4, because that's the 1/4 out here, that'd be 1/4 times, and then this would be half of 276 is 138, and plus 332 plus, and then half of 302 would be 151. And so putting this into our calculator, okay, we could get, if we add these up and multiply by 1/4 or divide by 4, we get 155.25 people. Okay, now what does this mean? Let me slide up. So 155.25. Okay, so this is the average number of people. Okay, and I know it has to be people because I'm finding the average of the number of people, right? So this is 155.25. This is the average number of people waiting in line during the first 4 hours. Okay, so we can make that into a statement. During the first 4 hours, the average number of people waiting in line is 155.25 people. Okay. And so that's how you do this one, okay? So we got to look at the difference, okay? You're going to see average number of people, that'd be the average number of people, that'd be average of L of t, right? Average number of people, average of L of t. How do you find the average of a function, right? It's 1 over b minus a times the integral from a to b of whatever the function is, right? Versus this one above was estimate the rate, right? So we're estimating a derivative and we're also estimating an integral, right? With both of these two questions, okay? All right, guys, that's it for today. Hopefully this is a quick lesson for you guys and hopefully it goes well. All right.